Yeah, Alan. And he didn't give it me just now, he gave it me a couple of years ago. So, has everybody heard of the Internet Assigned Numbers Authority? Most of you have, right? So this is the place where they give out the identifiers for the internet and where they register them all in databases. So we basically split them down into three areas. Numbers, which are IP addresses and autonomous system numbers, domain names, and protocol parameters. Now, most people don't think about the protocol parameters, but some that as engineers you will know are things like port numbers, etc., private enterprise numbers. There's a few others, but there's about 3,000 different types of protocol parameters used on the internet, and the IANA is the home pretty much for all of them. So let's talk about the naming function. So there's basically two types of activities we do in the naming function. I'll go back to the previous slide. One is root zone management, where all the TLDs are registered. And the other one is basically the function of signing the root zone, the what we call the DNS trust anchor. So there's been a few changes at the IANA recently. We have a root zone management system. It's a piece of software. It's been around for about 20 years. It's now being refreshed, or it's actually just been refreshed. A couple of big changes, apart from more modern software, because you don't want to be running on 20-year-old software. We've added some increased functionality for the TLD operators. It used to be that you could only sort of have one admin contact and one technical contact. And what we added at request from the community is something we call basically a change contact, a person who can make the changes. So they're the authorized person to authorize any changes for the TLD's information. And that can be as many people as you want, but it has to be people. So if you work at a CCTLD or a GTLD and you want to have more people authorized, you can do that, but you can't use role accounts. It has to actually be individual people. I'm using my notes here because these are Kim Davis slides, and I'm doing them on his behalf. The other thing that we're working on is some additional features. Time-based one-time passwords. Did I get to move my slide? Not yet. I'm just trying to find my slides here. Okay. So we're also trying to move to a time-based one-time password. So we're all familiar with these, right? If you use something like Google Authenticator, or you get a password sent via SMS to your phone, the system currently doesn't support that. We are going to support it. The technical work is easy. Like, it's really not that hard to actually implement this because you can buy packages, etc. The administrative side of it, a little bit more complicated. We have literally more than 1,000 contacts in there, and each one has to get their token. And we're going to have to figure out the systems, not just for giving out these tokens, but what to do when they lose them. Now, these aren't that hard. These are things that other organizations have done, but we've not done it before. So it's going to take us a little bit of time to make sure we get that all in order. The other thing that we've updated is our technical checks. So the technical checks, when you make a change, if any of you have made a change at a TLD, many of you don't work at registries, but if you do, then two things can happen. You either pass the check or you fail the check. We've updated the software that if we see faults, we can just send you a warning in advance. So you get a warning back and then you can fix it, and it just saves time. The pass-fail thing used to cause all kinds of delays in the actual changes. And we're hoping by giving people warnings in advance when we see problems, they can first be aware of the problem, because you're not always aware of technical problems. And secondly, fix it. So when they come back for the changes, it's a much smoother process. The other part of the DNS or the naming functions is the trust anchor. So we just had a discussion on DNSSEC, so you all know this now. But it's a hierarchical system. DNSSEC is hierarchical, and it starts with a trust anchor, which we put into the root zone. The signing of the key is done by the root zone signing key. And we have to change that every now and again. So the one thing that we do with that key and the generation of that key that is maybe different to most systems you've seen where people generate cryptographic material is we do it completely in public. So rather than generate our material in a closed, secure place where nobody can see what we're doing, which is sort of the normal paranoid security way of doing things, we actually completely open up the system. Now, you can't all walk in and start touching the machines, but anybody can go into a viewing area and watch the system. And we also stream that system online. Now, if anybody's got 6 hours with nothing to do and they really want to, what did Jalvi say? You're not sleeping, you're just contemplating or meditating. If you want to meditate for about 6 hours, I totally recommend watching this. It is all about process. It's very important that it's transparent and that everybody can see it, because we need to have trust in the way things are signed, but it is not the most exciting thing you will have ever seen. I suggest if you're really into this kind of stuff, go watch it once or twice. If you happen to be in the neighborhood when it's happening, you can go watch in person, but it's never going to be a blockbuster movie. Although you may have seen sort of on TV and things when people talk about people with the keys to the internet. Well, that's about the people we call our trusted community representatives. They carry pieces of data on cards that are important for generating those keys. Now, they don't have the keys to the internet, but that does make for better TV. But we do need these trusted individuals. And although it says Asia on here, these are Kim's slides, so errors, here's the good stuff's mine. We also need people from Africa. So if you're interested in representing the community and actually being part of these exciting ceremonies, come talk to me or go to that URL and see if you want to apply. So we need people from Africa on this because we need representation geographically. We also need more people from Asia too, which this slide was presented last week in Kyoto. So ICANN.org/TCR, that's Trusted Community Representative. Think about it. I don't think it's a massive burden. And it's actually interesting. And the most thing is you get to meet all the other TCRs, and it's an interesting bunch of people. And you can see a photo here from a whole bunch of them at a ceremony. The people in the suits are ICANN staff. For some reason, we all feel like we have to dress very formally for this event. None of these people wear suits to the office, just to be clear. But for this event, everybody dresses up like they're going to a wedding or to court or something. It's a very formal event. So we have to change that key, right? It doesn't get changed often, and we don't make the change lightly, but you do occasionally need to revolve your keys and put new keys out there. So we've done that a total of once. And it was an interesting project to get there. And we're looking at rolling it again. So at some point, we will generate a new key signing key. We're also looking at the problem of algorithms. So Yazid was talking about SHA-256 and the various different algorithms. At some point, we're going to need to upgrade that algorithm to something else. We don't know what it is. Obviously, every engineer has his own idea about what it is, and I'm sure there'll be lots of interesting discussion about not only which algorithm, but how we roll the algorithm. It will be highly documented. It will be very public, because once again, this key is the key to the DNSSEC in the DNS. So we need to get it right, but we're going to do that with community. So there is a group of community representatives, mainly engineers, who are sitting around talking about where do we go? What's the next algorithm? What's the future? And at some point, we will change the key to a different algorithm. I think we're a little way out. So you can see there that the next process is ongoing. And the rollover to key 3, because I said we've only done it twice, is in 2025. Then we'll generate another key in 2026. So there's a whole process that this goes through. It doesn't happen overnight. It actually takes us years to generate and roll a key in a safe way, because we want to make sure that we don't do anything that would disrupt the internet, because if we disrupt the internet, people are going to get upset. Well, a lot of you are here for the NRO this morning, so number resources. So there are basically 3 types of numbers in the number resource pool. So we actually give out these numbers to the regional internet registries. If you were here this morning, you would have heard that. There's 5 of them. There are some numbers that we actually give out at IANA. They're multicast addresses. It's very few of them, but those come directly from the central pool. But the rest, there's private use. If you've heard of private IP addresses or RFC 1918 addresses. But for the most part, these resources are given out by the regional internet registries. So IP version 4 addresses, 32-bit, what we call the dotted quad notation, sort of, the 10.1.1. whatever. They're pretty much gone. We ran out of those in 2011. That's when the last /8 was given out to the RIRs. There was 1 given to each. And then a little bit later, we recovered some. And those were given out about 5 years ago. Wasn't a large amount, but we recovered some IP4 addresses, and those went back out to the RIRs. So basically, from an IANA perspective, a global perspective, no more IP version 4. Done. But luckily, we've got IP version 6, the new, better, sexier version of IPv6. It's a lot more bits, 128. So it is 4 times as many bits. It is a massive namespace. However, that's what they said about IP version 4 when they first did it. But what we've done, along with the IETF, is we decided that we would only start with a very, 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 I can't remember how many verys it was, but it was a lot of very small pool of addresses. And I think somebody showed this on the NRO. Yes, but you can see on here that it's like a fraction of a fraction of a fraction. It's a very small amount of the existing address space. So we've got plenty of that. That will be somebody else's problem after I retire and probably my children retire. We've got a long way to go. It was designed that way. We actually learned something from what we did with IP version 4. And instead of giving out in large blocks, if you remember the beginning of V4 with A's, B's, and C's, we're giving out still very large blocks, but as a percentage of the address space, minuscule. Somebody told me once there is enough addresses to number every grain of sand on the planet. And I asked them why they'd want to do that. And apparently it was just like a metaphor or something. Autonomous system numbers. So these are the numbers that we use to actually group addresses, and these are the numbers we use for routing, right? So if you run a network, you've seen an AS number, two types of these, 16 bits. 32 bit. We talked a little bit about this at the NRO as well this morning. I've only just found the laser, so I'm going to play with it. So in the 16-bit or the 2 bytes, obviously that's 65,000 something. That's what 8 bits give you. 32 bits is just a lot more. We've ran out of the 2 bytes or the 16 bits AS numbers at ICANN. Now, once again, the regional internet registries still have some, but we don't have any. And we've got plenty of 32-bit. Got about 98% still left. So we should be all right for a little while. And I suspect at some point the IETF will look at that and go, okay, well, let's do something else. Let's maybe go to 64-bit or 128-bit, who knows? But we're doing okay there. I'm not going to go into the protocol area because there's 3,000 of them and we don't have all day. But like I said, some of them are, a lot of those are actually assigned for a particular technical use, like port numbers or for a particular network. If somebody's got about a year, we could go through them. One of the important things about IANA is accountability to the community. So for all the different services we do, for example, with the numbers, we have agreements with the RIRs and the NRO. There are SLAs, service level agreements, and we give out regular reports on what those are, and they get adjusted as appropriate. We've not had many adjustments to them. They've typically, when we've done adjustments, it's like, that is too strict an SLA, and you know, it just doesn't make sense, even though we're meeting it. IANA has met 100% of their SLAs. And for the protocols, of course, we have the IETF that we have an SLA agreement with. We have regular reports to them, and then we have these annual community reviews to see if the SLAs are the right ones for purpose. And that's it. That is Kim's presentation, or IANA's presentation. So that is the IANA in a nutshell. If you have questions about particular protocols or particular things that are happening at the IANA, I'm happy to take questions or come and see me afterwards. Thank you. And is the shirt okay? Okay. Shoes on. I did not bring Birkenstocks. I'm sorry. Thank you.
I've got a question. Yes. I saw one of your slides was talking around replacing the HSMs. And because of the ceremony, I assume that you're still going to go with the physical HSMs. And I would like to know what the position is around.
Oh, the HSMs. So these are the modules where we store the keys, the physical modules. So there are different levels of security that you can apply, and we apply the absolute topmost level of security. And there are only basically a couple of providers in the world that can make these. And the provider that we were using basically stopped providing these. And they said, these are too high security. We're only going to do the level below. We found another provider. We are looking at the HSMs. We've got them in the lab. So we will be replacing the old HSM with a new one, and we will be publishing all the details as we do about everything else. But at the moment, we're still in the research phase. We are going to stay with physical HSMs. We've still got a few years of life on the existing ones. So we're not going to wait until, you know, that they're at their end dates, but we are already actually in the lab with new HSMs, trying to figure out if these actually meet our requirements. On paper, they do, but you never trust a supplier, right? You don't trust their paperwork, you actually test it. So we're in testing at the moment. I'm not sure when that testing will be completely filled, but we'll be very public about it, about what we chose and why we chose it. So it's a good question. Thank you.
Can I add to that?
You may.
2 weeks ago, Canada.ca, they did a rollover. They rolled over their key signing key, At the same time, they changed the algorithm, I presume from 8 to 13. And they also rolled over their hardware because the hardware grew much older, much faster than the software that we all need today. So they did basically three rollovers in one, and it was a success.
That was very brave.
It was very brave. Yes, we saw this poor guy sitting there in the Zoom chat, but it worked. And they are also going to do a write-up. And what their problem was trying to share keys between two different HSMs can be rather difficult and fun.
Well, you're not supposed to be able to do it, right? If it's like at the highest level.
They got people to rewrite certain bits of software.
Yes, so I think in theory, the new HSMs, you can actually transport between HSMs. So you can actually share the keys. The old ones you can't. So we would have the same problem. Well, I wonder which ones they use. I should go talk to Jack and find out.
Talk to Jack.
Yeah. Thank you.
Thanks, John. We'll move on to the next and last session. Yazid,